An EC fan can save energy against an AC fan, but there is no honest universal percentage. Savings depend on the motor, controls, operating point, and hours at each load. Let us separate those effects and calculate one transparent payback example. First, keep the air side equal. Compare candidates at the same airflow, the same static or total pressure, the same air density, and the same installation boundary. Comparing maximum airflow, motor nameplate watts, or two different impellers does not isolate the motor technology. A conventional AC fan commonly uses an induction motor. The stator creates a rotating magnetic field, while induced rotor current produces torque. The rotor turns slightly slower than that field. This slip, plus winding, magnetizing, and mechanical losses, consumes part of the electrical input. An EC fan uses a permanent magnet brushless motor and electronic commutation. The supply feeds a rectifier and DC bus. Semiconductor switches energize the windings in sequence. Permanent magnets avoid induction current loss in the rotor. Depending on the model, the integrated controller can set speed from 0 to 10 volt, PWM, or digital commands. That architecture can improve motor efficiency and part load control, but it does not make every EC fan automatically better. The impeller, operating point, controller losses, and installation still determine wire-to-wire performance. Compare complete fan electrical input, not motor labels alone. Now separate motor savings from control savings. At full load, the gap may be modest when the AC motor is already well selected. In a variable load system, speed control can create the larger opportunity. For the same fan in a friction-dominated system, airflow changes roughly with speed, pressure with speed squared, and power with speed cubed. At 80% speed, the ideal power trend is about 51%, at 60%, about 22%. Real systems deviate, so use measured curves, but the cube trend explains why part load hours matter. Be careful with the baseline. A fixed-speed AC fan throttled by a damper differs from AC with a well-matched variable frequency drive. A VFD can capture much of the speed benefit. Any remaining EC advantage must be proven with measured input power, including the external drive, filters, cabling, controls, harmonics, and installation cost. Here is a deliberately hypothetical example. An air handler operates 1,000 hours per year at high load, 2,000 at medium load, and 2,000 at low load. Metered input for the existing AC system is 10, 8, and 6 kilowatts in those modes. Its annual energy is 10,000 plus 16,000 plus 12,000, or 38,000 kilowatt-hours. At the same three duties, the proposed EC system is measured at 9, 5, and 2.5 kilowatts. Its annual energy is 24,000 kilowatt-hours, giving a modeled reduction of 14,000. These numbers teach the method, they are not a promise for another project. At 12 cents per kilowatt-hour, annual energy savings are $1,680. If the complete installed upgrade costs $4,500 more than the baseline, simple payback is $4,500 divided by 1,680, about 2.7 years. For procurement, also include demand charges, uncertain hours, maintenance, filter loading, and commissioning. Verify voltage, control, EMC and harmonics, fault behavior, minimum speed, protection, temperature, sound, mounting, and service access. Test a range of electricity prices and load profiles. A fan that cannot integrate reliably is not a lower-cost system. After installation, trend kilowatts with airflow, pressure, speed command, and operating hours. Correct for major filter or production changes. The best savings claim can be checked after commissioning. EC usually pays when the complete fan is efficient at the required duty, partial load hours are substantial, controls reduce speed, and annual savings justify the premium. With an efficient AC motor and good VFD, payback may be longer. Calculate it, do not guess it. For a project-specific comparison, send Longwell the existing curve or measured kilowatts, required airflow and pressure, annual load hours, electricity cost, voltage, control, and installation envelope. We can return a curve-based review with every assumption visible.